Stephen, we're good? Oscar at North Central, are you having a good day today? I hope so. Celeste told me all about you. All right, so my friends, asymptotes. Right now there are two flavors of asymptotes. Those flavors are horizontal and vertical. There's actually a third flavor. They're called oblique asymptotes or slant asymptotes. They are asymptotes that are kind of off at an angle. Not perfectly vertical, not perfectly horizontal. They're called slant asymptotes. We are not going to worry much about slant asymptotes. We are going to worry tremendously about horizontal asymptotes. And we're going to worry about vertical asymptotes. And we're also going to throw in holes at the same time. So let's get some hands on this. If I asked you to find horizontal asymptotes, what would you do? Don't call it out. Let's get some hands on this. How would you go about finding horizontal asymptotes? I see one, I see two, I see three. Myra, how would you find horizontal asymptotes?
You find the degree, the highest degree on the
Okay. In the event that your function is the easy kind and it's like a polynomial over a polynomial, we call this a rational function. If the degree of the numerator is bigger, what happens? If we're restricting ourselves to rational functions, if the degree is bigger in the numerator, then the answer would be? There is no horizontal asymptote. If the degree is bigger in the denominator, y equals 0. Thank you for learning from Lewis's, what was that, 4 mistakes yesterday? And in the event that there is a tie, you take those leading coefficients, you look at the fraction, and you say y equals a over b. Everybody okay? Like, that's what you know about horizontal asymptotes coming out of pre-calculus. There are these tricks that you know. But this is only for the world of polynomial over polynomial. Yes, ma'am?
The other way.
That's right.
Okay. The other way you can find it is to find the end behavior.
Oh, thank God. If it was legal to give you a hug, I would. Okay, horizontal asymptotes, when we're not in like baby land, horizontal asymptotes, we're talking about like end behavior. That's why I was doing this awkward thing yesterday. Okay, horizontal asymptotes, I want to know what happens as x approaches infinity, and don't fall for it. It's not just what happens as x approaches infinity. And you have to check to see what's the limit as x approaches negative infinity. Now, could these be the same value?
Yes.
Absolutely. Could you have a horizontal asymptote on one side but not on the other? Give me a parent function that does that. Horizontal asymptote on one side but not the other. Horizontal asymptote over here but not this way. David, give me one.
E to the negative x.
E to the negative x. E to the negative x is decreasing from left to right. So that has a horizontal asymptote over here but not over here. Any other ones? Any other parent functions, horizontal asymptote on one side but not the other? I can think of at least one more. Yeah.
The natural log of x.
Natural log of x is an increasing function. It increases without bound. It actually has no horizontal asymptote. I understand that if you looked at the graph, it kind of looks like it flattens out. And you might think horizontal asymptote, it actually keeps increasing. Okay, there's at least one more. David took e to the negative x. How about e to the positive x?
Yeah.
Yeah, okay. All right, good. So in the world of horizontal asymptotes, this pretty much sums it all up. In the world of vertical asymptotes, where do I start? Where do you start? Where do you start? Where do you start? Carmen, where do you start?
You look at the denominator.
You look at the denominator. Why?
So that it can be equal to 0 and find your candidate.
Ah, there you go. I always call those the candidates. The candidates just means that the denominator is equal to 0, right? Because we don't want the denominator to be equal to 0. Bad things happen. World explodes. This is how it works. Good. Now, just because the denominator is equal to 0 doesn't mean you have a vertical asymptote. When you get your candidates, say like x equals c, the next thing is you're going to go back and you're going to say, all right, what happens to that function, if I take the limit as x approaches c, and I get as an answer either positive or negative infinity, then your conclusion here, you have a vertical asymptote at x equals c. But if what you get, the limit as x approaches c of f of x, is some number, some finite number L, like 5, 12, negative 19. Adelaide, do you remember what that tells you?
There's a hole.
There's a hole in the graph. You have a hole in the graph at the point c comma L. Whatever your candidate is, that's where the hole is, and whatever your limit value is, that's the y coordinate. Polymon, you okay? You sure? I don't know that I'm 100% believing you. All right, so before we go a little crazy, why don't you guys take out your calculator? I've got a new function for you. 5e to the negative x over e to the negative x minus 1. And I want to see from the calculator, do you have evidence that there are asymptotes? Bless.
Thank you.
If all goes well, your graph ought to look something like mine. Maybe your window's a little bit different. Can I get somebody who could drive my laptop in the back? You're basically going to drive the calculator for me. David, are you willing to like take this on as like a regular job?
Sure.
The pay is great. It's great pay, so you're going to go back there. Okay. Based on the graph, is everybody okay that there are clearly some asymptotes here? Vertical asymptote? Yeah. Horizontal asymptote? How many?
Horizontal?
Horizontal asymptote. How many are? You see one?
See one.
You see one. Which one do you see?
One. 2.
There's this guy over here. There might be a different one that's over here. Right? This is why when I ask you to check horizontal asymptotes, you need to check both sides. It's about both ends. So one way you can do this, if you want to use the calculator, David, here's where I need your help. You could do the trace feature. So we're going to go to menu, trace, graph trace, and you can just like move to the right. Using like the right arrow. So you can like go to the right, and that point is going to move, and it's going to move, and it's going to move. And what are we looking for? We're looking to see that the y values are getting closer and closer and closer to something. And so as David keeps going, is everyone pretty convinced we have a horizontal asymptote? And that horizontal asymptote is going to be
0.
It should be 0. Now the weird thing is that what we're seeing over here is like scientific notation. This negative 3.07 e to the negative 5 means take your decimal and do what? Go to the left 5 spaces. That's a really, really, really tiny number. So I am pretty convinced based on the work here that I have a horizontal asymptote at y equals 0. I want to get the other one as well. So let's trace to the left. You don't have to do it this way. There's another way you could explore the ends. Anybody remember the other way? What else could you do if you wanted to figure out the y values and you didn't want to do this slow, painful method? Maybe I'm asking that question badly.
Oh.
To find the horizontal asymptote.
See that they both have the same value. Just do 125 divided by 1.
Okay, hold that thought because I want to come back to that. Louis, what were you going to say? You were going to say that as well? Okay. I won't hold that thought, we're gonna come back. David, can you do Control T for table? Right, the table might be another way for you to go about doing this. So you hit Control T, and what I wanna do is if I wanna head towards negative infinity, I could go up, so I'm at 0, I'm at -1, -2, -3. I can see those values. Now, even that moves kind of slow. And remember we had the option of like changing the table settings. What were the steps there? Menu. So menu, table, and then edit table settings. And you can change the table start, but the other thing you can do is just change independent to ask mode. And that might be a little bit better. Hit OK. And let's put in numbers that are approaching negative infinity. It'd be like -10, -100, -1,000. Yeah, -10, -100, -1,000. Your calculator is struggling a little bit for the decimal accuracy. It's saying that you're exactly at 5. That's actually not true. But you can see from the values and how everything's trending that you have a horizontal asymptote at y = 5. Everybody okay with that? We've got some evidence. We could use the calculator. However, we're in calculus BC, so let's put the calculator away and do it the way that like real men and women of calculus would choose to do this. There is only one right way. David, you can come on back. You can join the flock again. Thank you so much. Did you find any money on my desk?
No.
Good. Okay, there's no money actually there for you to find. So let's do this the limit way. Let's do this the limit way. Let's start with horizontal asymptotes. How do we find horizontal asymptotes? David, what do you want to do?
Look for the behavior.
You're going to look for end behavior. Now here's the thing. I heard Aaron and then I think Lewis said look at the degrees. There is a problem with that thinking. That works if it's a polynomial over a polynomial, like x squared over x cubed, x to the 5th over like x squared. Only polynomial over polynomial is going to work that way. That's not what we have here. So you're kind of stuck like Chuck. Let's find the limit as x approaches infinity of 5e to the negative x over e to the negative x minus 1. Well, let's see. How am I going to find this limit? Can I plug in infinity?
No.
Never. Never. What I can do, though, this is a great candidate for some mental math. What happens as x approaches infinity? As x approaches infinity, what happens to e to the negative x? E to the negative x is going to approach 0. Okay. So what about that denominator?
No, it's like, wait.
0, right? This guy's going to 0, minus 1.
Negative.
Negative 1. And in the numerator? 0 times 5, we're going to get 0. So your limit? 0. The conclusion. What's your conclusion? We found the limit as x approaches infinity. We get 0 as an answer. Lewis, what's the conclusion here?
You still need to find to negative infinity.
Wait, one more time?
You still need to find what it approaches negative infinity.
But hold on. What's your conclusion? You took the limit as x approaches infinity. You got 0 as an answer. The conclusion here, you have a horizontal asymptote. Right? Because of this, I can say with confidence that I have a horizontal asymptote at y = 0. I'm not saying that I'm done, Lewis. I'm saying that I checked one end and I came up with one horizontal asymptote. Palamon, can you maybe switch seats so that you can like see what's going on and engage here? Limit as x approaches infinity, we're getting y = 0. We're not done because we need to check the other one. And this is where we're going to have a little bit of a problem. Limit as x approaches negative infinity of 5e to the negative x. Have a conversation with somebody near you. What's your plan? What's that limit?
Asymptote, yeah. Like I said, like the same thing which is there.
Is that?
You're gonna get infinity over infinity.
As x approaches negative
We're
infinity.
gonna have to find the
E to the
called derivative.
E.
Instead of looks like this.
I can't plug in negative infinity, but I can ask the question, what happens as x approaches negative infinity? And as x approaches negative infinity, what happens to e to the negative x?
Infinity. Approaching infinity.
Approaches positive infinity?
Yes.
What happens to the numerator?
Infinity.
Infinity. What happens in the denominator?
Same thing.
Infinity minus 1,
Infinity.
right? Infinity.
Yes.
How do we feel about infinity over infinity?
No.
We don't feel it.
We don't feel. We're at that point in the school year, seniors are like, no, I don't feel anything at all. Infinity over infinity, it's another indeterminate form. Not an answer. If this is an indeterminate form, which it is, what we're going to need to do is try some cleverness, some algebraic cleverness. And this is one that you probably won't see coming. What I'm going to do is I'm going to say, let's take this limit as x approaches negative infinity of 5e to the negative x over e to the negative x minus 1. And I'm going to multiply by e to the x over e to the x. Okay, blowing your mind a little bit here, I know. Number one, is that legal?
Yes.
Yeah.
Giselle, why is that legal? Okay, thank you for the honesty. E to the x over e to the x is equal to 1. This is, right? Are you okay? You're like, oh yeah, that one we're good? Oscar, okay, we're good? E to the x over e to the x is fancy 1. Now, my first question was, is that legal?
Yes.
Yes. Would any of you have actually thought to do that?
No.
No.
Probably not. Let's call this divine inspiration, right? An angel whispered to me and said, hey dude, try it this way. Okay? Stop talking to me, I don't talk to strangers. Okay, so first question is it legal? Giselle? Yes. Still on yes, yeah. All right, is it better? Does it make the problem better? Check it out. Multiply the numerator by e to the x. 5e to the negative x times e to the x. Bases are the same. The exponent rule I need you to know here is add the exponents together. What do you get? You get 5 times e to the 5 times e to the power of 0. In the denominator, do it again. E to the negative x times e to the x is e to the 0 minus 1 times e to the x, e to the x. The reason that this is better, limit as x, oh that's a negative infinity, isn't it? Sorry. E to the 0 you guys know is 1 times 5 is 5. E to the 0 is 1 minus e to the x. And you might think, well, that is no better. It is better. It's a different kind of worse. It's a different kind of pain. Take the limit as x approaches negative infinity. What happens?
1 minus negative infinity.
You're going to get 1 minus, what happens to e to the x? E to the x, if you're approaching negative infinity, oh, negative infinity is that way. 0. What's your limit?
5.
5. You're getting 5 over 1 minus 0, which is 5. We're going to get it right this time. What's the conclusion? There's another horizontal asymptote. Where is that horizontal asymptote? There's a horizontal asymptote at y equals 5. I care greatly about your conclusion. You're not just getting me a number to make me happy. I want a conclusion. We did this to find horizontal asymptote. We did this to find horizontal asymptote. We're done?
No.
No! Because We haven't found the vertical asymptote.
Ah.
Dang it! All right, this one's gonna be easy. Vertical asymptote. Give me the vertical asymptote. Vertical asymptote. How do I find the vertical asymptote, Andrew? What do I do?
Was to look at the denominator and
I look at the denominator and I
look for candidates.
look for the candidates. I'm going to set this equal to 0 and solve it. Solving an exponential equation, we can do this. I can say this is e to the negative x equals 1. E to a power is equal to 1. E to what power is 1? E to the 0. The exponent must be 0. The other thing you could do is take the natural log on both sides. So negative x equals 0, x equals 0 is, I do not want to hear vertical asymptote. That's premature thinking. It's your candidate. If you're going to have a vertical asymptote, this is where it is. All the friends okay? All right, let's do it. So now I've got to test what's the limit as x approaches 0 of 5e to the negative x over e to the negative x minus 1. As x gets close to 0, what's happening in the numerator? X gets close to 0 in the numerator. Not infinity.
No, it's not.
If x is getting close to 0, e to the 0 is 1. So you're going to get 5. In the denominator, x gets close to 0, e to the 0 gets close to 1. And you might look at that and be like, oh darn it, that's a problem. Yes, and a little bit of no. We're not plugging in 0, we're getting close. So the numerator gets close to 5. The denominator gets close to 0. Getting close to 5, getting close to 0. What happens to the whole fraction?
I mean, we go to approach infinity.
5 divided by really small numbers. If you need to do it on your calculator, feel free. 5 divided by really, 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 really small numbers is going to get close to 7. No. It's going to approach one of the infinities. And it's going to depend on what side of 0 you're approaching from and all the good things. So whole or vertical asymptote? Whole or vertical asymptote?
Vertical asymptote.
Has to be a vertical asymptote because we're approaching an infinity. So my conclusion here is going to be vertical asymptote at x equals 0. Nice. 2 horizontal asymptotes, 1 vertical asymptote, and good news, it 100% matches what we already knew. 100%. Oh, one more, please, one more step. There's like a billion. Okay, this is a tough problem. This was selected to push your brains. And some of you look like some brain fluid is leaking out. It's okay, we'll get the mops. Okay? All right, so we've got about 25 minutes left, which is hopefully going to be enough time to push your thinking a little bit more. What I'm going to ask you guys to do is on page 36, take a couple of minutes to read. I'm going to put out my supply kits. There are highlighters in there. If you read best with a highlighter, feel free to use your own or use one of mine. Sorry. Stephen, can you pick one?
No.
Wait, no, flip.
Page 36. Everyone silently reading. We'll talk in a little bit. careful attention to the definitions here. Right, the reading is about determining how do you decide which function is growing faster. The definitions at the top are telling you how, if you're going to test two functions, how do you decide which one's growing faster? Right, you're going to look at the ratio of the two functions, and if that ratio comes out to be infinity, which one grows faster? The top or the bottom?
The top.
Top grows faster, right? Think about numbers, and this should make perfect sense, right? If I have a big number in the numerator and a small number in the denominator, what happens? I'm approaching infinity. If, however, the whole fraction is going to approach 0, then it must mean that the one in the bottom is bigger. And in the event that I get a finite number, like 5, 7, -12, we're going to say that they grow at the same rate. What we're testing here is end behavior. It's a limit as x approaches infinity, so we're saying, hey, what happens all the way out here? But we're going to test the ratio. So for example, let's see if your instincts serve you well here. 100x squared plus x, or x cubed plus 1. Which one grows faster? Trust your instincts. Which one grows faster? The x cubed plus 1 grows faster. Polymon, how did you make that decision? You're multiplying a number by itself, by itself, by itself 3 times. Okay, that's one way to say it. How else? What other ways did we decide that x cubed plus 1 grows faster? This is an easy question. You guys know the answer here. The greater degree, right? These are things that you guys already know. So based on this work here, right? So I went through this morning, no, that's a lie, like last year. And I said, okay, if I want to compare these two functions, I'm going to look at the limit as x approaches infinity, 100x squared plus x divided by x cubed plus 1. If I just plug in infinity, well, what's going to happen? I'm going to get, what are we going to get? I'm going to get the indeterminate form. I'm going to get infinity over infinity. I can't find my markers. Who's hiding stuff on over? Alright, if I just tried the plug-in step here, I'd get infinity in the numerator, infinity in the denominator. Indeterminate form, don't like that. If, however, I multiply by 1 over x cubed and 1 over x cubed, Giselle, legal? You sure? Okay, because this is really 1, yeah. Now, the reason why it's better, once I distribute that 1 over x cubed through, look, I've got 100x squared over x over x cubed stuff. I can simplify, now take the limit as x approaches infinity, 0 plus 0 in the numerator, 1 plus 0 in the denominator, whole fraction is 0. We're good? What's the conclusion? David, what's the conclusion?
The denominator grows faster.
The denominator goes faster? Right, if my limit is 0, what I'm going to say is something like, therefore, g of x equals x cubed plus 1 grows faster. Well, grows faster than what? Grows faster than f of x equals 100x squared plus x. Honestly, that's all we're going to do. We're just going to look at some of these and decide which one grows faster. Some of these you're going to be able to do on site and no work is going to be needed. Others, if you needed to test the limit as x approaches infinity using the calculator, that would be okay. I could graph this function here, both functions on my calculator, and say what happens as x approaches infinity, and if I get 0, bottom grows faster. If I see no horizontal asymptote, top grows faster. If I approach some number like 12, we're going to conclude they grow at the same rate. Okay, so with that said, here's what I need you guys to do. I need for Polymon's team, you're going to go through and each one of you is going to be given 5 pairs of functions. Polymon, you've got pair 1, pair 3, pair 5, and pair 8, and pair 9. 1, 3, 5, 8, 9, and I said polymoan, but this is like team polymoan over here. At 9:30, I need a definitive answer in each pair, which one grows faster. You guys got this? Okay, the good looking folks in the back. You've got pairs 2, 4, 6, 7, and 8, because I really don't trust polymoan's team. Okay? So whatever I just told you guys, don't ask me, I don't remember. Okay, up front, the good looking kids. You guys are going to do pair 2, pair 5, pair 7, pair 9, and pair 3. 2, 3, 5, 7, 9. At 9:30, I need definite answers from each of your group on the 5 that you're doing.
The first one.
And if you guys want to do a little divide and conquer work, that's fine. All right, pair 1, which one grows faster? G of X grows faster. That, I mean, if that's fine. If this is one that you can just know, that's okay. The other option would be to write limit as x approaches infinity, f of x over g of x. So that's the answer. Here's my conclusion. You will have to leave that. Okay. So what's the first pair I gave you guys?
Second one, or the third one?
Pair 2. Okay, pair 2. I bet you guys can look at that. Yeah. Which one grows faster?
Wait, there.
Uh-oh, which one? F of x. X to the 4th plus 2x grows faster? Completely.
3?
Easy peasy. How'd you decide?
No.
I looked at the
That has
degrees.
-2.
So you looked at the degrees, and f of x is the bigger degree, therefore f of x. As you go down into the list, it's not going to be as easy. Okay. So you can do like that, like take the limit of like one function over another, see what you get. Feel free to grab it on the calculator if you need to as well. Okay. Okay. Friends back here. Alright, easy pair for you to decide. 4. 2 and 4. What was 2 7? X to the power of 4 compared to x squared, which would grow faster? X to the power of 4. Probably didn't even need to do any work.
Because the x to the 4th,
Find 4.
and this is negative.
How'd you get through the walls?
I just,
As a greater rate.
well, no, I just took out all of this group.
Are you sure?
Anyways, yeah.
Would you bet a pinky finger on
I
it?
took out all of
You sure?
this.
Just
No,
checking.
Eric doesn't explain math at all. He's like, I just
So,
do this and this.
this is great,
and
like,
then
this would be
that.
great supporting work. You're like, oh, I'm gonna take the limit. Oh, and look, x to the 4th plus 2x over x squared. The degree is bigger in the numerator. I know it's gonna be infinite. Okay. But if you didn't know, you could also graph this on the calculator and reach
And
it
you know that
that way.
infinity
Yeah,
is
just-
0.
If you're gonna write limit as x approaches infinity. Just like polynomial, it almost brought a tear to my eye.
Oh, yep.
If only I
Yep,
could
I
write.
had that.
If it's an obvious one, feel free to skip that one, right? You can just kind of do that in your head when you say, okay, pair 3, what's the conclusion here?
They grow at the same rate.
They grow at the same rate. And you know that because you examined the degrees? Perfect. Okay, you could also show me this, and what would the limit be?
Oh, number 5, which is E.
You could do that.
X to the 4th plus 2x over 3x to the 4th minus 2x. What's that limit actually gonna be?
Oh, that's a lot. You guys got number 4.
We don't have to do number 4.
You guys have. I mean, you can just write each of those skills.
X to the 4th plus 2x.
Oh, were you saying something? Yeah, it makes sense.
X to the 4th plus 2x over 3x. Minus 2x. I bet you know what that one is.
Here.
Yeah, I'm like,
Okay,
were we supposed to do 5?
Yes.
Are you sure?
Yes.
Don't let us want to trust me.
Degrees are the same, right? And the degrees are the same, you look at the coefficients and say,
Oh, man.
Whoa.
Did you find that?
No, I didn't think so.
Yeah,
He said words are
Yeah.
What?
With about 2 minutes left, if you need to divide and conquer a little bit on the harder problems, feel free.
It was
No, that's me.
Oh,
That's me.
Wow, that's right.
Say darn. Great googly moogly, I dropped my pen.
Oh, feces. Oh, feces. Say that one, Kim. Oh, feces.
Please don't bring it.
Aaron, would you like to say something to your family?
I don't know what you're talking about. Oh, feces.
I turned it away. Timing, buddy, timing.
The blue one.
Wait, you are.
Oh, true. Speak. Speak.
Work that I have to do, but I'll be here. So you can work. Summer assignment done in the way that needs to be done. For the men here.
Yes.
Are you guys gonna be able to stay with me tomorrow?
I have work, but I could see. I work at 4, so I should be okay. But if not, I could just, I don't know.
All right, so my timer is about to go off, so let's just pretend that happened. Oh, and it actually did. All right, pair number 1, which one's growing faster? Who had pair 1? You guys had pair 1. G of x grows faster. That's the one I'm going to underline. Pair 2, x to the 4th plus 2x compared to x squared. Which one's growing faster? Okay. Pair 3, x to the 4th plus 2x compared to j of x. J of x. F of x. Both. If you were to take the limit, if you take limit as x approaches infinity, let's make sure you guys get this one down in your paper. X to the 4th plus 2x over 3x to the 4th minus 2x. That's how we actually test the limit. This is how we test the rates. Taking the limit as x approaches infinity of a polynomial divided by a polynomial. You guys know the answer here. What's the limit? The degrees are the same. What's the limit? Oh, upward here. X to the 4th plus 2x over 3x to the 4th minus 2x. We're taking the limit as x approaches infinity.
1/3.
Degree 4, the way you guys would decide, you look at the leading coefficients, and the answer is 1 over 3. The conclusion,
They grow at the
They
same
grow
rate.
at the same
the functions are growing at the same rate. If you get infinity, the top grows faster. If you get 0, the bottom grows faster. But if you get a number, they grow at the same rate. Oh my God. They grow at the same rate. Yes, let's pretend that's what I wrote. All right, pair 4, x squared compared to the square root of x. Which one's going to grow faster? H of x should be growing faster. Pair 5, x to the 8th compared to e to the x. You probably had to go to your calculator on this one. If you did the analysis, you're going to get limit as x approaches infinity of x to the 8th over e to the x is 0. That's what you should be getting out of your calculator. What's the conclusion? If you're getting 0, which one grows faster? E to the x. Or L of x equals e to the x is the one that grows faster. Okay, natural log of x divided by the square root of x. Who is responsible for this one? You said pair 6. M of x is natural log of x, k of x is the square root of x. Which one grows faster? It should be which one?
M of X.
M of x. I don't agree. Did you make
Oh,
the
wait,
right?
no. I was thinking about the yeah, it's K of X.
Okay, so for all the friends that didn't get a chance to do this one, your setup, you'd look and say, okay, what's the limit as x approaches infinity of the natural log of x over the square root of x? Lewis, did you make that ratio? No. Did you do the other ratio? Okay. I'll tell you, if you do limit as x approaches infinity of natural log of x over the square root of x, what you're going to get here is 0. The conclusion, which one grows faster? If you're getting 0 as the answer, which one grows faster? Right, the one in the denominator grows faster. Okay, pair 7, you're going to have to do this on the calculator as well. Limit as x approaches infinity. E to the x over e to the 3x. What did you guys conclude? We've got 2 groups that were given pair 7. What, Carmen, what did you guys decide? N of x, e to the 3x? Okay, so that must mean that when you did this limit, you get 0, so the denominator grows faster. Agreed. All right, pair 8, e to the x compared to 3 to the x. Limit as x approaches infinity of e to the x over 3 to the x. 2 groups had pair 8. What did you guys get for the limit?
We got P, right?
Wait, did you guys have e to the x and 3 to the x? What'd you get? Which one grows faster?
Infinite,
L of X.
that's what.
L of x?
Yeah,
Yeah.
she's trying to say, she said the other one.
Not 3 to the x?
Oh, yeah.
E to the x compared to 3 to the x? Yeah.
Isn't 3 larger number than e?
Yes.
So
3 to the x would grow faster. 3 to the x would grow faster. And pair 9. I think I didn't give you guys enough time to do the calculator exploration. Sorry, friends at North Central. Take your time. Okay, e to the 3x compared to 3 to the x. The one that's going to grow fastest? E to the 3x. Here's what I want you to do. Take 1 minute with your team. I want you to put these functions in order from slowest to fastest. Find the slowest function for me. All the way up to the fastest.
Natural log of X.
The ones
Right? Natural log of X is M of X after 2.
Wait, we did K of X first, right?
Okay,
wait,
Just K of X.
no, but that's.
That's why that's so going to be M of X.
Like on all of them do that order, or just the one?
Out of all of them.
be square root of x.
Should you do?
Yeah.
No, the second one.
Second. Perfect fraction.
L, natural log of X.
Anybody find the slowest growing function yet? What is the absolute slowest one on this list? Lewis, which one do you have as the slowest?
With natural log of X.
Okay, so natural log of x got compared to the square root of x, and natural log of x was found to be
Slow.
slow. So natural log of x, I agree, is the slowest one on the list. What one after that? Somebody not named Lewis. Give me another slow growing function. Steven,
Square root of x.
square root of x. After that one? All right, we're picking up the pace here. Natural log of x was really slow. Square root of x was a little bit faster.
I think x squared.
Okay, x squared. All right, I agree. After that, which one? Which one?
That's all right.
Although I think with this one there were some ties, right?
Yes.
Which one? X squared grows a little bit faster, which grows a little bit faster, but x squared grows at the same rate as what one? Oh, I didn't have another x squared, did I?
No.
Okay, after x squared, which one? We've got natural log of x, we've got square root of x, we've got x squared, the next one?
Wait, there are two.
I think you've got two choices here of what it could be. Lewis, what could it be?
X4 plus 2.
X to the fourth plus 2x does grow faster than x squared. The other option you could put here would be the 3x to the fourth. Give me just 1 second. After the degree 4, which one?
X
E to the
to the 8.
oh,
It should be x to the 8th that comes next. After x to the 8th,
E.
E to the X.
e to the x. After e to the x,
3 to the X.
3 to the x. After 3 to the x, e to the 3x. Just make sure you've got that copied down. You won't need it for tonight. You won't need it for tonight's homework, but tomorrow I want to start class. We're gonna wrap this up. I'll see you guys later. I would definitely encourage you, if you can stay tomorrow with me from 1:30 to 3, make arrangements to do so.
Huh?